Today we're discussing science and national security. ASP is co-hosting an event with the American Geophysical Union to discuss how science is important for national security. We are joined by General John Adams, who will be speaking at the event with us.
Thanks, Andrew. It's a privilege.
I'll start with just a simple question. Why do you think science is important to America's national security?
Science is important because, in fact, it has provided us with world-class military equipment that we've given our warfighters to defend this country since we've been a country. We've seen since the very beginning a number of military uses of technology which would only be possible if we have the basic research and the scientific and technology base to develop those systems to put them in the field. I'll just give you a couple of examples.
Sure.
Armor plate. The reason why our armor plate was able to protect our warships and our armored vehicles in this past century is because American technology did the basic research and did the development of that armor plate to make it suitable for combat, protecting our services, all of our services. The reason why we're able to field the world's best aircraft is because American science and technology developed it. And it didn't start at an Air Force base or at a Navy base or on a carrier. It started in laboratories. It started with academia, industry, and government working together to look at something that we need and then develop it all the way to the field. But it's important to have that nexus among government, industry, and academia. It starts with basic research through development, through fielding. Without that, we don't have the weapons and equipment that our warfighters need.
Now, you talk about this nexus, and that's very important. What do you think are the challenges within all three sides of that nexus going forward?
We are very strong in basic research, and we see that if we just look at a couple of, I'll call them research and development clusters. Palo Alto, California is one where the emphasis has been primarily on high technology, electronics, and high technology development of just a variety of, just look at the semiconductors industry, which is really centered there. And it's not just academia, it's not just Stanford and Caltech, it's also our national laboratories that are in that area. It's also our industries that we have there. Intel, for example, they work together. So we have a cluster of technology there, and you could say the same thing for Boston with MIT and the number of industries that are up there working on some of the same problems. But what's important is this group of people from industry, academia, and government coming together at an early stage, at the research stage, to look at what are the problems that we need to solve so that we can put the weapons in the field or the equipment in the field in sometimes 15 to 20 years.
Yeah.
It's important to sustain that. We're not talking about something that's got a 5-year horizon. We start today to research the problems and to develop the systems and equipment that are going to get fielded in 2040. And I'll just go back to semiconductors because I happen to know a little bit about that. And it's also something we need to discuss in terms of the vulnerabilities. The United States was the leader in developing semiconductors. And we still have a very large part of the semiconductors market. And both for civilian and military purposes, it's important that we continue to keep that huge part of the market so we don't have that whole supply chain migrating to other countries, some of whom are our strategic competitors. But that's what's happening, because it's not so much the basic research today that's developed in other countries. We still have the strong basic research, but the development is the issue, and the fielding is the issue. And the clustering of those three is the issue, because it's easier to develop the early stages to do the research in the United States, but it's much easier to package it in East Asia.
Sure.
And so the supply chain is running there, and just like every other corporation that wants to do vertical integration, once you have the labor working on the packaging, on the assembly of the equipment in Asia, it also brings the research and development there. So we're finding that, in fact, we're losing some of that research capability on semiconductors to our sometimes strategic competitors in Asia. This is a problem for national security. We don't want to lose that research and development lead. We want to keep that, and for that reason we have to remember it's connected to the rest of the supply chain. Give you another example.
Yep.
Machine tools, 5-axis machine tools, which is the machines that make the machines, to put it simply. The United States was the leader in developing 5-axis machine tools. Not anymore. We make a very small amount of the 5-axis machine tools, and the reason is because it's easier to make them in other countries. The labor's cheaper. Not only is the labor cheaper, but the other countries have in many cases provided subsidies to the 5-axis machine tools in their countries so that they can pull the supply chain into their countries. So the United States, we still make 5-axis machine tools, but not as many, and we don't have a very large part of the market. So we need to think about this brings me to a really important point. This is all got to be based on strategy. Back in the 90s, Andrew Marshall, who's the head of the Pentagon's Office of Future Projects, and he's a brilliant guy. He's been doing this for 40 years. And I hope one of his future projects is actually to develop a way to keep him in business for another 40 years. But Andrew Marshall designed back in the 90s what he called the 20 crown jewels of the defense industrial base, which was an attempt not to pick winners and losers, because I know that's one of the frequent criticisms of the government being involved in deciding which industries get supported and which don't. But he tried to take a look at our strategy for the future and select those specific sectors of the defense industrial base that would support it. We need to do that again. Because the one he developed in the 1990s, as good as it was, as tied to long-term strategies as it was, it's not 1990s anymore. Right. We've got to update that for the next few decades. So we need to do something like that. I don't know if it's 20 or 15 or 35, but we need to decide which of the sectors are most important. Gets back to the original question, why is science so important? We have to develop technologies that are achievable on this planet to support our warfighters in 20 or 30 years. To do that, you need the smart guys in the labs and academic research facilities, in the government laboratories, and in industry, in our defense industry, to help select those technologies, because they're the ones that are going to know it. The warfighter tells the basic researcher, hey, this is my problem. How can you help me fix it? And then they have this dialogue, and it's got to start with the basic research, and it's got to go through development. It has to continue to work.
So it's science, talent, knowledge throughout the whole length of the supply chain for 20 years.
As long as it takes to develop that technology. But also it's important to remember that even when you develop the technology, and again, go back to semiconductors, for example, the semiconductors industry is the classic industry. Moore's Law, for example.
Yeah.
I mean, we're constantly finding ways to make things smaller, more energy, more capacity. It's never going to stop. Where's the end result of the semiconductor industry in terms of size and power? Only by staying involved in the research and maintaining the research and development nexus are we going to find out what the limits are. We're not there yet. Maybe I can give another example.
Sure.
And this is a small one, but it's important. The Hellfire missile, which we use on a wide range of platforms to perform all kinds of great national security missions like killing bad guys. Every service has a variant of the Hellfire missile.
Right.
The propellant, the subcomponent, the butynetriol subcomponent of the Hellfire missile that makes that sucker fly is made in China. Now, why is that? It's because we didn't have the ability to make that subcomponent in the United States. The company that did it went out of business. So we are now trying to develop two different processes, one chemical, one biochemical, to develop the subcomponent butynetriol, which is part of the propellant for the Hellfire missile. We're doing this with a cooperation between our U.S. Defense Department and industry. We wish them luck, because we need to get rid of that dependency. It's very important to keep our scientists engaged in national security issues.
That's great. That's a great example. Thank you. Thank you for joining us, General John Adams. And we look forward to seeing you at the AGU ASP event.
Thank you for the opportunity.